day, Bayaw! Welcome back to our YouTube channel, Bayaw Tutorial. In this video, we are going to solve a problem from Thermodynamics and Heat Transfer, Chapter 5, the second law of thermodynamics. So here is our problem. A steam power plant obtains 260 gigajoule per hour of heat from a furnace. The heat losses from the steam as it flows through the pipes and other components to the surroundings air are estimated to be around 18 gigajoules per hour. Determine the net power output and thermal efficiency of this power plant if waste heat is transported to cooling water at rate of 127 kilojoules per hour. So in this problem, we are going to find the two unknowns, which is the net power output and the thermal efficiency of the power plant. So here is our diagram for this problem. So the rate of our heat absorbed is equals to 260 gigajoules per hour, and the heat that comes from the furnace enters in our system and it releases into the sink or into the higher atmosphere region. So our solution, the rates of heat supply and heat rejection of power plant are given. So the power output and the thermal efficiency of this power plant are to be determined. So we have assumptions for this problem. First is the plant operates easily or steadily. Second is the heat losses from the working fluid in the pipes and other components are taken into consideration. So here is the total heat of rejected power plant, which is equals to 127 gigajoule per hour plus 18 gigajoule per hour is equals to 145 gigajoule per hour. So here is the value for our rate of heat rejected. So then the net power output of the power plant becomes the rate of the network output is equals to the difference of the rate of heat absorbed and the rate of heat rejected. So by plugging the given values, we have 260 gigajoule minus 145 gigajoule per hour is equals to 115 gigajoules per hour. And because it is the rate of network output, its unit is megawatts or watts. So we need to convert this 115 gigajoule per hour into megawatts. So 1 megawatts hour is equivalent to 3.6 gigajoules. So by multiplying these two given values, we can now get the value for the rate of the network output, which is equals to 31.42077 megawatts or 31.42 megawatts. Now, the thermal efficiency of the plant is determined from its definition. The thermal efficiency is equals to the network output, the rate, divided by the rate of the heat absorbed. And by plugging in the given values, we have the 115 gigajoule per hour, which is the value for our network output at gigajoule per hour, and the value for our heat absorbed, which is equals to 260 gigajoule per hour. So by dividing these two given values, we can now get the value of our thermal efficiency, which is equals to 0.442308, and multiplying by 100, we can now get the value for our thermal efficiency, which is equals to 44.23%. So now we have the value for our net power output, which is equals to 31.42 megawatts, and the value for our thermal efficiency of the power plant if waste heat is transported to cooling water at rate of 127 gigajoules per hour is equals to 423%. So that's it.